Hello friends, welcome back to my YouTube channel. So in today's video we'll solve one problem of cantilever beam by using the moment area method. We'll solve a problem. In previous video we have seen the procedure of the cantilever beam, how to analyze this cantilever beam by using the moment area method. So we'll solve a problem on that today. So this is the given problem. Find the slope and deflection of the free end by using the moment area method. So this is the given cantilever beam. Here throughout the beam 10 kilonewton UDL is acting, and here point load of 20 kilonewton is acting. From here to here distance is 3 meter and here to here is 3 meter, and the AB section has the I value 2I and BC has the I value I. So first what we have to do is, first thing we need to find the support reaction. So I will tell you how to find this by using I will directly find the support reaction by drawing the bending moment diagram. Here first we have to draw the BMT diagram. So by first we'll solve the bending moment at point C. So here at point C is free end. No, at free end bending moment will be 0. Here it will be 0, and at point B I will solve bending moment at point B will be, we have to see only this much of, here the 10 kilonewton UDL is acting, so 10 into, at the distance of from here to here is 3. So if you convert UDL to point load, so 10 into 3 is to convert the UDL to point load, and our UDL always act at a distance of L divided by 2. L divided by 2 is nothing but our length is here 3, no? 3 divided by 2. So solve this, it will come out as, by solving it will come out as, so it is also negative, no? If you convert UDL to point load, so it comes like this, it moves downward. So whichever moving upward we need to take the positive, and whichever moving downward we need to take the negative. So if you convert UDL to point load, it moves downward, so downward means it is also negative. Minus 45 will be the bending moment at point B. So minus 45 means it comes here 45, and similarly bending moment at point A, bending moment at point A will be, we need to see from here to here. Here on UDL is throughout the section UDL is acting, 10 into, at the distance of here to here is 6, here to here is 6, and if you convert UDL to point load, UDL always act at 10 into 6 is to convert the UDL to point load, and our UDL always act here center. Center means at a distance of L divided by 2. L divided by 2 is nothing but our distance is 6, no? 6 by 2 means it will come 3. It is also moving downward means negative, and here point load is also moving downward at a distance of 3 meter, no? Minus 20 into 3. So solve this, it will come out as minus 240. It is also negative. Minus 240 means it will come here 240. So UDL is there, no? The bending moment diagram will come parabola like this, and here also like this. It is also negative, it is also negative, both are in negative. So now next we need to find the, we need to draw the M divided by EI diagram. So whatever the value we got, we need to divide it by EI value. Here 240, here I value is 2I, no? We need to solve it directly. Here I value is 240, no? 240 divided by 2, from here to here is 2, so it will come out as 120. It will come out as 120. At point A the value will be 120 divided by EI, so it is also minus, no? Negative. And here 2I is related to this, here 2I is related to point B, no? 20 kilonewton. We need to divide 45 divided by 2I, and later we need to divide 45 divided by I also. We need to do it twice. Here we need to calculate. I will show you one by one. First I will show you one by one. 45 divided by this 2i I will do. Later I will tell you. 45 divided by 2, it will come out as 22.5. 22.5 divided by ei. And from B to C here the value is 45. For 45 we have to divide again by I value. So if you do 45 divided by I, it will come out as minus 45 divided by I. So here once and here also, because this our point B is related to this section and it is acting center. Now we need to divide once with this value divided by 2i and this value divided by this one I value. We need to divide it by twice because it is acting at the middle. No, we need to divide it by 2, and here the bending moment is 0. So the diagram will come, it will come like the parabola like this. Again join here also parabola like this. This is also negative, this is also negative. This is how we need to draw the m divided by ei diagram. So now we need to find the slope and deflection. Slope and deflection at the free end. Free end is here C. Now we need to find the slope at point C. This is our first theorem. To find the slope at free end C, call it as theta C. For that we have the formula theta C minus theta A. We need to go from this side to this. Now we want to find the slope at section C. No, we need to go from right side to left side. So here right side is we have the point C. That's why theta C minus theta A is equal to area of m divided by ei diagram. And see here we need to find the area of these sections. Now I will draw it how to find. So before that, see here at point at point A our slope and deflection will be 0, because if you draw the elastic curve, our value at fixed end becomes 0 for the elastic curve. For the elastic curve will come like this. This is point C, this is point A. At fixed end our slope and deflection value becomes 0. No? That's why we need to, here our theta value becomes 0, because point A the slope is 0, only theta C will come. So now area of the, I will show you here, this diagram I will draw here only. So this diagram will be like this, no? This is like this. This is point C and this is B, this is A. Here at point A we have the two sections. Here 120 is also acting there. 120 here, 22.5 here, 45 here is 0. So now we need to find the area of this one and area of this one and area of this one. To find the area of the triangle, we have the formula length into height. No, here length is 3 meter, here also 3 meter. Length is 3 meter into height of this is 22.5. From here to here 22.5, here to 22.5. So if we do this, so the value will come 3 into 22.5, 67.5. 67.5. And similarly for area of this section, this is parabola. No? To find the area of this one, we have the formula. To find the area of this one, we have the formula area 1 divided by 3 into height into length, h into L. So 1 divided by 3 into, here the length is 3 meter, and height of this one we have known the height from here to here. No, here to here is 120 and here to here is 22.25. No, now we want to know this much. No, now for this much we need to minus 120 minus 22.5. If you do, we'll get this much distance. So if you do, how much we'll get? 120 minus 22.5. if we do, the value will get 97.5. 97.5. No, this is our 97.5 from here to here. Now add here 97.5. our A2 will come, 3 will get cancelled, 97.5 A2 value. And similar for area of this one, A3 is equal to, the formula will be say 1/3 of length is 3 meter and height is 45. from here to here 45. So this one will get cancelled. A3 will come out as 45. So now the area of M divided by EI diagram will be A1 plus A2 plus A3. So substitute all the value. A1 is 67.5 plus A2 is 97.5 plus A3 is 45. If we do, our theta C will come out as 67.5 plus 97.5 plus 45. if we do, it will be 210 divided by EI. So it is clockwise. If you don't want to put the negative sign, then write it here the clockwise, because these all values in negative. No, that's why. This is how we need to find the slope at point C. Now we need to find the deflection at the free end. So deflection is nothing but our delta C at this free end we need to find. So we have the formula for that. Moment of M divided by EI diagram at point C. We need to find at point C. For that we have the formula A1 into CG of the area 1 plus A2 into CG of the area 2 and A3 into CG of the area 3 we need to find. So now we got the A1, A2, A3 value. No, so first I will write the all the value. A1 value will 67.5 into, now for x1, to find the x1 of this rectangular, we have the value, wait, for AB we have the this point close 22.5 is acting at the center. Here 3 meter means here also 1.5, here also 1.5 distance. So our here to find out the x1, here for AB we have the 22.1, therefore this point load is acting at the center. We have the distance total 3 meter means here also 1.5, here also 1.5. Now we want to find the wait, this is our C. For point C we need to find this to this much of distance we want to know. From here to this much of distance we need to find. Here is 1.5. No, 1.5 plus 3. So our x1 will becomes 1.5 plus 3 meter is nothing but 4.5. We need to find the slope at point C. No, we need to take from here to here this much distance. Similarly at point AB there is one more load is acting, that is 120. It is also 120. It is acting here. So we have the here at point A we have the load 67.5. So this is 67.5, not 22. Another we have the loads 97.5. One more point load is acting, that is 97.5. For this, to find out the from here to here distance, this is parabola. Now having for that we have the formula 3 by 4 into L. So 3 by 4 into our L is 3 meter, from here to here is 3 meter. Now we need to see the from here to here. Here to here means this is plus 3, no? Now we need to solve it. Three divided by 4 into 3 plus 3. If you do, it will come out as 5.25. 5.25 will be the 5.25 will be the x2 distance from here to here. Our A2 value we got was 97.5. No? For this load we have the distance of CC, how much? 5.25. Now similarly for A3 we have the value 45. So 45 is acting here. The 45 is acting again here. The load 45 acting here. We need to see this is also parabola. No, this is also parabola means we have again 3 by 4 into L. So 3 by 4 into 3, if we do, it will come out as 3 divided by 4 into 3. If we do, it will be 2.25. So distance of x3 will be 2.25. For this one we have the distance 2.25. We need to see from here to here distance. Here to here is 2.25. 2.25 distance. Now we got all the value. Now solve it. (67.5) into 4.5 plus 97.5 into 5.25 plus 45 into 2.25. If you do, the value will come 916. So 916 divided by EI is the value of deflection at point C. This is also downward. This is how we need to find the deflection at point C. Here our problem ends. So if you like the video, like it, share it and subscribe for the more videos. Thank you for watching.